I'm Carl Moberg. I'm the CTO here at Avassa Systems. I brought with me Fredrik Jansson, who's our field engineer, senior field engineer. And today we're showing a platform for managing applications at the edge. And in this section, we're going to deploy and update on-site edge container applications. And we're going to do that working with our persona Appliffer, as she gets access to a nice infrastructure that is actually tailored to her tools and needs and culture. So we're going to deploy and upgrade an application using our UI and then switch to do it through a pipeline.
Yes. Sorry, guys, I have a question because
Go for it.
So far you never mentioned Kubernetes.
Mm-hmm. Sounds like a setup.
And usually when you talk about containers at the edge, Kubernetes is part of the game anyway.
Yeah. So we run on the container runtime. We don't use Kubernetes for the edge.
So you provide all of the placement scheduling.
The ones that are needed. The ones that are needed. Yes.
So you replace everything Kubernetes needed at the edge.
And that's a surprising small amount of things you actually need at the edge. Because most of the things people think of when they think of Kubernetes is actually in the container runtime, not in Kubernetes itself.
That's big.
I think it's small. It's smaller. It's actually operationally smaller.
I think you remove one huge part of edge deployments if you remove Kubernetes.
We remove way more, because Kubernetes itself is not enough. You need somewhere between 10 to 15 additional components on top of Kubernetes to give this sense of platform. So Kubernetes is one thing you get rid of. You also get rid of your Kafka or Pulsar. You get rid of your OPA. You get rid of your CNI, your service mesh. You get rid of a lot of things that Kubernetes pulls with it to the edge.
Let's move on. So now I actually logged out. I'm going to log in as our beloved Appliffer into the same system. And lo and behold, it looks very similar. But she only has access to 31 sites, the one that happened to be in Europe and a few ones here in North America. And now we'll leave that, and we're actually going to start looking at how you deploy applications in our system. And we're going to do a really small app first, just to give you a feel of what the components are in our system. And then we're going to deploy a more realistic application after that. So we have this application that we use for demo called a visitor counter. And I'm going to define here.
You type, I talk.
Yeah, sounds good.
Applications have names, they have versions, and as the rest of the industry teaches us, they have services. A service is just a list of containers scheduled on the same host. So think of it as Affinity made easy. Containers have names. In declarative environments like this, they have URLs to point a system like this to say, where do I find this container image? In centralized systems like single Kubernetes clusters, hitting submit here would literally start the application. For us, it's a two-step process. You first define and prepare the application, and then you tell the system under which circumstances do I want a replica of this application.
Yes.
Yeah, sorry, go ahead.
No, that's great. That's great. So the application image itself, the Docker image that we built, actually resides on GitLab, because that's what we use for our demos and our code and so forth. So this is Docker.io or ECR or JFrog or wherever you push your images. You tell our system where to find them. The only thing, as Carl said, we do at this time is we download that image into the control tower to prepare it for distribution. If I reload here, you will see that we have downloaded that image. So now the next step is to take that application we just defined and tell the system where you want to run it. And you do that through a deployment. So I will add a deployment. Call this visitors. Pick my app. Choose my version. And here comes the labels that we use. So here I can say I want to run this in Europe. So that will select out of those 30-something sites that I have, the sites that happen to be labeled with Europe. And now when I hit submit, things will start happening in the system. If I go back here, we can see that it's actually sending these work orders to those sites that you should be running this application. They check, they don't have the image locally, and they will actually download that image and start it up. So when I go back to my app here, I can now see that I'm running this particular application. For some reason, that Arlanda site is slow. It's coming up now. On all these places, I see what version I'm running. So let's do a quick change. Let's say I want to do an upgrade of this one. So our development team pushed a new version, 2.0, to GitLab. I'm going to change the image version here. And again, when I hit submit here, nothing really happens, but the system downloads that 2.0 image. So now if I go back into my deployment, I can actually change it here. So let's say we wanna roll out to 2.0. For some reason, I'm brave. I want to run this everywhere. So I can do system type equals edge. That means in our lingo, everywhere. But I want to use the Europe sites, for example, as canary sites. And I'm going to put this into manual. That means we're going to roll out version 2.0 in the European sites, and then the system's going to stop. So then I can take a look at it, make sure it's up and running, it does what I want, and then I can ask the system to continue. So I'll hit submit here. And maybe you wouldn't do 25 in the real world and save 6, but that's what's happening at the moment. So as you can see now, we're updating to version 2.0 on the European sites, while the North American sites are still waiting. So let's check one of these out. I'm gonna pick this one, Bratislava. I can actually go here, make sure it's up and running. I haven't had any restarts. I can click a container. Maybe I want to check something out in the container. You can actually do like a Docker exec or kubectl exec through the browser into the container. So something I want to look for as a developer, make sure everything is good.
And your health probes and all that are the same way, looking for regular expression match on the command that you... So.
Yes.
Yes.
And that's used for the canary testing as well, the same health probe.
It is.
Exactly.
It is.
Yeah.
Yes.
Plus a timer, usually for the canary.
Yeah.
So not just pass
to,
it,
to
but
wait, then
for,
check periodically until it
exactly.
doesn't die.
Exactly.
As long as it doesn't die right after.
There you go.
So can I ask a question about, you said it downloads the image and then it prepares it for distribution. What's involved in the preparing for distribution? What does it?
So actually, it's two steps. So we literally, Docker or Podman pull from the external registries, usually, a couple of places. We put that into a local registry we have in the control tower. And when we start deploying, it is imperative that we have the container images corresponding to the running containers at all times, because we want to be able to reschedule applications in the face of an upstream outage.
Okay, so this is all about the software. So what happens if the software package that's been written and downloaded won't run on the hardware that exists?
Oh, the power of containers.
Okay.
Literally. Because you can do all kinds of, let's call it context checks. So for example, one of the trickier parts of this system that you guys will never see is multi-architecture scheduling. What happens if we have a site that has both x86, 64, and ARM, and you have an application that only has one, right? What do we do now in order to make this easy for Amplifier? And what do we do if there's a multi-architecture container, because that's now a thing. So you can have multiple architectures in a container, but it doesn't actually match one of the architectures you have on site. So that whole matching of the small but important requirements from a container, it is small though. So you can't, you can't compare with like RPMs or I heard guys mention FreeBSD, like FreeBSD packages or something like that. It's a very small set of requirements. And it usually has to do with ABI or CPU architecture. Yeah.
But I still miss, something after you said that you don't use Kubernetes. What happens if I need to protect that application at the edge? I mean, data protection. I'm a storage guy, so sure. I always think about these stupid things like protecting data. And so I have my application on a remote site, and I don't have, anything that is, like Kubernetes data protection application or whatever that can pull my data from there in a consistent way, especially if I have many containers managing different sources of data. So I need consistency and everything, right? How do you do that?
So in our case, we use the same storage backends again as Kubernetes because it's related to the container runtime, not to the Kubernetes orchestrator. In our system, we have a distributed secrets manager, so every data, both in flight and at rest, is actually encrypted using both tenant, site, and host encryption keys. Because one of the major issues for several of our users is the physical theft of the edge computers themselves. So managing secrets here is orders of magnitude harder than to do it in any type of cloud where there's no physical access. And that's all part and parcel of our underlying architecture.
Yeah, but what happens if I need to recover my data?
If you have to
recover the data. I mean, so you lose everything because there is a fire or whatever.
Yeah.
And you need to install everything new and you want your data back.
Yeah, so you have to have some sort of storage, and this is a really interesting can of worms, by the way. You have to have some storage architecture that doesn't rely on singular hosts at the edge because they will burn through grease, spills, they will burn through all kinds of reasons. So that's not something, the edge container management, Kubernetes or no, can fix. You have to reliably have offsite copies, for example, for all kinds of things.
Yeah, okay, maybe we'll discuss this.
Sure. More than happy to, because I've already destroyed the time schedule here, so move on.
Let's assume this application is good. It looks good on this site. We have checked the other sites. It's all up and running. So by clicking continue here, I'm actually going to ask the system to continue the rollout to the rest of the sites. So hopefully this gives you like at least a basic understanding of what the application specification is and the deployment is to our system.
Yeah, maybe if there's one thing we leave them with from this section is that, again, we're using this through a web UI, but it's both working on declarative definitions of what an application is, combined with, and here's what we think is the kicker, specifications defining under which circumstances should this application be started. We showed you region, very basic stuff, very fast. Mm-hmm. You can also pick on any of the stuff that we glean from the Linux environment. So for example, only if there's a camera, only if there's a GPU available. Most AI workloads need that. Only if there's a particular amount of RAM or vCPUs available. That's all in the labeling universe here. So the application team can map on that, which usually makes the platform team a little nervous. But that's for another day. Okay, are we done?
Question.
Is there any limitation to scale of number of nodes that can be supported with the tower? And how are you addressing the managed service provider market for multi-tenant?
Oh my God. So having built systems like this before, we know that every order of magnitude brings entire classes of problems. We're now comfortable in the thousands. Mm-hmm. We're not comfortable with tens of thousands.
Okay.
So we think we have the architecture, but we know that that'll be different. We built this with full, deep, isolated multi-tenancy, which is, by the way, one thing that we never understood how we could do had we used Kubernetes at the edge. But we have encrypted isolation tenants here between them, including things like WireGuard between services and things like that, because we see that value chain, not only for the managed service providers. You would be surprised that there are, for example, retail chains that want to allow third-party ISVs, third-party software vendors, onto their in-store infrastructure. But of course, they shouldn't see the point of sales.
Right.
So it's actually key to many of our users.
And I just want to make sure I understood you correctly. That was a design decision to move away from Kubernetes to get that capability?
That was one of the reasons why we couldn't make Kubernetes work for us.
Okay.
Now I'm going to do another switch and actually going to show you how our customers typically use this. They start out in the UI, they do this manually a couple of times, but then they want to automate. And almost all of them, I would say all of them, has a Git repository in GitHub or GitLab or something local. So in GitHub, I'm switching into GitHub. I have a repository where you could think of, this could be a customer's repository where they push their point of sale app or whatever app, AI camera app that they want to deploy in GitHub. But what I want to show you is how you tie this together with our system. So The thing that I have in here, I won't go through this, but this is another application spec, the one we created before, but a bit more involved. It involves a bunch of containers. It needs secrets to function, credentials. It actually has a fluent bit part. I won't dwell too much on that, but that allows us to bridge our system into many other systems, CloudWatch, for example. So this guy needs Amazon access keys to be able to communicate back to Amazon once it's up and running. And the plan here is when I make a change to this deployment file, again, this is the deployment we just created. I'm going to change this in here to say, for example, country Sweden, if I can spell. And I'll hit commit here, and I'll show you what's happening. So we have created GitHub actions for this, and it's really just a YAML file that describes what should happen when changes are made to this code repository. And as you can see, it's not very long. It's about 50 lines. We download our command line tool from this particular control tower I'm talking to. We're logging in. We're updating these Vault credentials, Amazon credentials, for example, and then we push those specifications into our system. And fingers crossed, it's a demo. Hopefully everyone on a return here. Lo and behold, I actually have that new application, Theater Room Manager.
So when you're saying R right then, you mean the customer you're pretending to be?
Yes.
Okay.
Good.
This is Applifer. Good point. This is Applifer
Awesome.
talking here.
Yes.
Okay.
She has a GitHub repo.
Yeah.
She's been given access to Platrix infrastructure.
Yes.
And now we can see that her Theater Room Manager application through GitHub Actions has been pushed and operationalized.
Very cool.
On top of that. And she's literally a tenant. So she doesn't see all the details. She only gets certain access to certain parts.
What safeguards can you add as an infrastructure manager to application teams? Like, can you only consume X many percentages of hardware on site so they don't
Here's the equivalent of it depends.
Yeah.
Nowadays it's a policy language. There are policies for that.
Right.
You can cut and slice in many ways.
Yep.
Surprisingly low refinement in the industry yet, because people don't have really internalized the operational nightmares that may come out of this.
Yeah.
So, but there's a policy language for that.
Right.
And although you demoed that with GitHub Actions, it was just a series of command line steps. So you could build that in code build on AWS or as a Lambda.
Oh, yeah, absolutely. We've done this on AWS, GitLab, of course, since we use that, and GitHub, and actually Azure.
Azure as well, and then Jenkins plugin to manage.
I mean,
that as well.
it really comes down to, are you able to execute curl?
A series of command lines. Yeah.
And you can even use only curl for this, but it just happens to be way easier using our command line tool to do this. Very good. It's up and running, and I just really quickly want to show you. So I said it's actually talking to CloudWatch. So I'm actually logged into CloudWatch here, and hopefully if I refresh, you can see that it has created a log group, and it's actually pushing those application logs to CloudWatch. CloudWatch happens to be our poison. Maybe you have Stackdriver or Elasticsearch or something else.
And when he says our, he means Applifer's.
Yeah.
So it's Applifer's choice.
Yeah.
He loves her GitHub.
Yes.
And her CloudWatch. Yeah.
Secrets wise, you hold the Vault.
Yes.
Does it support or plans to support other?
As backends, yes, both of them.
Yep.
So HashiCorp
Great.
and usually CyberArk. Yeah. The big issue here is how do we actually allow for example, certificate roles over 3,000 locations from a singular point of view?
Yeah.
And how do we not help people build stuff into container images, but surface them the way container images want them to do, dynamic environment injection, mounted volumes, or local APIs?
Yeah.
All produced, of course, in the site, because we can't rely on centralized secret or centralized vaults. You don't want to fall over because you can't reach your secrets if there's an outage.